All right, so one more algorithm for factoring polynomials. Factoring polynomials is a huge topic, so there are many different algorithms depending on the type of problem. And this type of problem that uses grouping involves a technique when there are four terms, the simplest of which would be ax cubed. They could be a higher degree, but cubed would be the simplest, plus bx squared plus cx plus d. So whenever you have more than three terms, or whenever you have exactly four terms, a technique to try, it won't always work, but the first thing you would want to try is factor by grouping. First thing you want to do is make sure that the polynomial is written in descending order. Once you've written the whole thing from largest to smallest degree, you want to group the first two terms and then group the last two terms, making sure that there's a plus sign in the middle. And there's a little adjustment you can do if there's not a plus sign in the middle. And then you're going to factor by monomial extraction. Remember ME, you want to take out whatever's common to both terms. So like in this case, you would have an x squared that you could divide both terms by, just in this first grouping. So if you pull out the x squared, you're left with ax plus b. And then you would duplicate this here, doing exactly the same thing. And if when you finish, if you have, trying to think how to write this the best way, say you have an x or let's say that you have an integer here. You're more likely to have an integer there than anything else. So some integer value, remember fatty z means integer, and you're left and you have ax plus b again. If you get these twins, if the two groupings are exactly the same, then you can factor by grouping by putting the ax plus b times, after you've taken those out, what's left? X squared plus z. Right? So this would be factor by grouping method. I think if you see a few examples, all of this will make more sense. So let's do that. So let's factor x cubed plus 2x squared plus 8x plus 16. So the first thing is check to make sure that you're in descending order on the variable. And so the variable third degree, second degree, first degree, 0 degree. So that part's done. And now you want to just automatically group the first two terms and then group the second two terms, making sure there's a plus sign in the middle, and there is. Now factor each grouping separately using monomial extraction. So what is common to both of these terms? What's the biggest common or the greatest common monomial factor? Well, clearly x squared will come out of both of these terms. And so now if I do that, I pull the x squared out and now just use my division. X cubed divided by x squared is x, plus 2x squared divided by x squared is 2. Plus, what is the biggest common, greatest common monomial factor in this case? Well, 8 divides both of these terms. So now I'm going to pull that out. And what's left? 8x divided by 8 is x, and 16 divided by 8 is 2. Since I got the twins, I can rewrite this. X plus 2, that's the first factor, and the second factor is everything else, x squared plus 8. And now let's check it just to prove that I'm properly factored. So I have x plus 2 times x squared plus 8. X times x squared is x cubed. X times 8 plus 8x, 2x squared plus 16. And if I write it in descending order, I have x cubed plus 2x squared plus 8x plus 16, and that's exactly where I started. So I've fully factored that polynomial. So let's do another example, and this time specifically look at what would happen if this was a negative. So I have x cubed plus 13x squared minus 5x minus 65. So if I just use the algorithm of grouping the first two terms and grouping the second two terms, I have a minus in the middle. So I have to make an adjustment for that. But first, let's look at why. Why on earth would I have to make an adjustment? Well, if I just throw parentheses in here, I've altered the order of operations, right? I have a -1 that has to be multiplied, or I'm saying that everything in here is multiplied by a -1. -1 times 5x, that just equals -5x. That's fine because that's what the original problem had. But -1 times -65 is plus 65. And the original problem was not a positive 65. The original problem had a minus 65. So we can't just willy-nilly be throwing parentheses into a polynomial because we changed the value if we have a negative outside. So instead, I'm going to rewrite this minus 5x, the x cubed plus 13x squared, not really a problem. But instead of negative 5x, I'm going to write plus a negative 5x. And then minus 65. So I'm going to make this small adjustment of putting a plus minus, because really minus 5x is exactly the same thing as add the opposite of 5x. But now when I group, because it's a plus sign out front, I'm not changing the value. The negative 5x continues to be negative like in the original, but 65 remains negative like in the original. So you always have to make sure that you have that plus sign in the middle. And if not, you just turn it to a plus minus and then do your grouping and you're good to go. Now let's factor out each group individually. What is the greatest common monomial factor for the first group? X squared. And now let's pull that out. X squared and do subtraction. X cubed division. X cubed divided by x squared is x. 13x squared divided by x squared is plus 13. Let's move to our next group. Greatest common monomial factor. Well, I have a negative. They both contain a negative that I can divide by. And they also contain a 5. So I can factor out a -5 from the first term and a -5 from the second term. Now, if I do that, my plus sign just comes down, right? We worked really hard to get that plus sign there, so let's make sure we keep it. I'm going to pull out a -5 times, do my division. Cancel the -5s, I'm left with an x. 65 divided by 5 is 13, and a negative divided by a negative is positive. I got my twins. That makes me pretty happy. So I'm going to take the twins out and then write down everything that's left. X squared. This time I can just write -5 because that's what that actually equals. Let's check our work to make sure we're not dealing with a negative problem and to make sure we have the correct answer, or the correct factors, I should say. All right, so now I'll distribute. X times x squared, x cubed. X times -5 minus 5x. 13x squared minus 65. Write them in descending order. And I got the original problem back, so I know these are the correct factors. Okay, again, I've done a whole bunch of work with algorithms in here. This is a grouping method. This is a method algorithm. Eventually, you're not going to want to write all of this out. Now, of course, you'll be writing this out every time because what you're actually learning is the algorithm. And so you have to show to me that you know the algorithm. But in the future, the algebra is really write the original problem, show the factored form. Just 2 steps. Eventually, you'll just have 2 steps. Write the original problem, show the factored form, maybe show that you've checked it. We'll do that for a while, but you won't do that forever. Not because it's not smart to do, but because you'll have a whole bunch of other work that you'll need to do, and time just won't really allow for constant rechecking all the time. But not checking now, at this stage of the game, is just a sign of laziness. Please do not be lazy mathematicians. We want to be hardworking, excellent mathematicians. All right, advertisement over. Let's do another example. So we want to factor 2x plus y squared plus yx plus 2y. All right, so the first thing we want to do is write it in descending order. Now, descending order can be tricky in a case like this because you have a y squared, this is second degree, and you have a yx, this is also second degree. How are you going to write this in descending order? Well, you have to choose a variable. We're either going to write in descending order on x or in descending order on y. And in this case, because I have a y squared, I'm going to choose to descend on y. So a second degree y term, y squared. So sometimes grouping method is useful if you're dealing with more than one variable in your actual problem. So if I have the example y squared plus 2x plus yx plus 2y, I can try grouping. I notice that I have 4 terms. I have 2 variables. That's very unwieldy, but let's see what happens. If I group the first 2 terms and then I group the second 2 terms, making sure there's a plus sign, then I can just ME each problem. So what do both of these have in common? Nothing. So there's nothing I can do. But I might notice that if I have a y squared and a 2y, I could certainly take a y out of each of those. And then a 2x and a yx, I could pull an x out of both of those. So sometimes you have to look forward and kind of see if maybe there's a rearrangement that will work for you. So I'm thinking y squared plus the 2y lets me pull out a y plus 2x plus yx would let me pull out an x. This one might actually work. So I'm going to group again. I'm going to do exactly what I planned on, which is pull a y out and then do division. Y squared divided by y is y. 2y divided by y is 2. Okay, that looks pretty good. Now if I group the second one, making sure there's a plus sign, they both have an x. 2x divided by x leaves an x plus yx divided by x leaves a y. I wrote that wrong, sorry. Got a little distracted. There's some screaming on the other side of the house going on. Not sure what that's about, but I'll finish the video and then go check. So I almost have twins, right? Y plus 2 and 2 plus y. But that really is twins because y plus 2 and 2 plus y are exactly the same thing. I can reorder them. So I'm going to pull out the twins, y plus 2. Now if one of these was negative, that'd be a problem. But because it's plus, 2 plus 3 is exactly the same thing as 3 plus 2, so they're the exact same number. And then what's left? Y plus x. So being able to do this and make this rearrangement takes a little bit of practice. Be patient with yourself. With time, you'll see those ahead and you'll be able to make those arrangements. But they will come up, and so you want to practice them and think about them because if they came up at a critical moment, like on a test, you'd want to be able to try different rearrangements to see if you could go ahead and factor by grouping. And I think it's a relatively short video, so I have time to check, so I'm going to do that. So y plus 2 times y plus x. Y squared plus yx plus 2y plus 2x. Rearrange these and I have y squared plus 2x plus yx plus 2y. And I have exactly what I started with. And in fact, I have factored this unwieldy, multiple variable, 4-term polynomial by grouping method.